So we'll have a chart that looks like that. Some questions are only going to be about pressure and temperature. Some questions will only be about pressure and volume. So the columns we don't use, we'll be able just to mark out, and you'll see me do that with the examples. You're going to fill in the known quantities, and then this is what we did in the simulation activity. You find the effect by dividing the big number by the small number within a column. So if you're dealing with a question about pressure, you'll just divide the final over the initial or the initial over the final. I always do the big number over the small number so I get a number greater than 1. And then I'm going to use an arrow to show the direction. That's going to help me solve these. One thing that I think would be helpful before we get started with an example is to review the units that you're going to see with these. So just in the space, I think the space may be, I'm going to do it on the top here. So in the very, very top of this handout, let's put a little review note for ourselves. All right, I want to review the units. So the units that you might see for these, first of all, pressure. Pressure had a bunch of units. All right, one of the units was ATM, that was atmospheres. We saw KPA. Can anybody remember any other units of pressure that we saw when we did converted those things? Pascals was another one. I don't think I'm going to have any of those on this particular assignment, but PA was one. There was a weird one that was millimeters of mercury. Remember there was one about mercury? There was one called torr, and even PSI. So unfortunately, pressure had like 6 different units that we had to keep up with. All right, my next letter on here is temperature. All right, the only temperature unit you can use on these is Kelvin. That's going to be really important that we always use Kelvin. If they give you Celsius, you have to convert it. It says always. Then I've got V. All right, what did V stand for again? Volume, good. Volume comes in several different units. We're going to see mostly liters and milliliters. So if you recognize a unit, you'll know where to put it in the table. If it's in milliliters, you know it goes under volume. And then we wrote down a number of moles a second ago. I'm just going to put in. It can stand for moles, molecules, or puffs. Like when you worked with the simulation, you could pump in a puff of air. Each of those was about 50 particles, if you noticed when you did that and you counted them. So that's going to help us fill out these tables, knowing the units. I'm going to highlight Kelvin there. It's always got to be Kelvin for your temperature, though. All right, now we're going to make our first PTVn table, and we're going to use it and solve a problem here. Does anybody need more time on these units before I clear it? I think it would be a good idea to. Why don't you just take a picture of it with your phone real quick or something so I can, on this iPad app, it won't save it. What's that? Okay, well, good for you. I appreciate that, actually. Let me take a screenshot of it, and then I can put it up later. Okay. Unfortunately, the way this thing works is it makes it really hard to save pictures. Maybe I can save it. Okay. All right. I'm going to come back to this after we do our first example, so it'll make more sense what all this is about. This says a sample of gas has a volume of 20 liters at a pressure of 150 kPa. What happens to the volume if the pressure changes to 300 kPa? So for each one of these, we're going to make a table. On the table, I'm going to start off with a big rectangle like that. My headings are going to be P, T, V, and N. All right, and then down the left-hand side, I'm going to say IF. What does the I stand for? Initial, good. What does the F stand for? Final, good. And then E is effect. All right, so let's check this out. It says a volume of 20 liters. Gunnar, I need you to turn around, please. So we've got a volume of 20 liters. Would 20 liters go under P, T, V, or N? What's liters? Good. Volume. It's the first one they gave me, and in the story problem it's the first. I'll just say 20 liters there. All right, and then it says at a pressure of 150 kPa. Oh, goes under pressure. As long as your unit is consistent, you don't even have to include the units in the box itself, just in your final answer you'd want it. So what two columns are not mentioned at all in this problem? Do they say anything about temperature? Temperature and number of particles. This question isn't about that. So I get to mark those two columns out and really simplify it. When you make your own, you don't even have to include those if you don't want to at first, but I like to include those. Then I've got one more piece of information from the problem. It says, what happens to the volume if, so I'm trying to find out what happens to the volume, if the pressure changes to 300 kPa. Again, it's kPa, it's pressure, it's going to go, that's my final pressure. Bless you. Now, the key to working through these things is finding an effect. If you have a column with two numbers in it, you can find the effect by dividing the big one over the small one. So I'm going to get this value right here by dividing 300 divided by 150. Within the column, I'm dividing the big number by the small number.
So 300 divided by 150, that should be 2.
That's 2. Good. Now, did the pressure go up or did the pressure go down as you go down the column? If it went from 150 to 300, did the pressure go up or did the pressure go down, Tyler? It went up. Yeah, it went from 150 up to 300. So I'm going to say up by a factor of 2. So the arrow turns out to be important in these things because the arrow helps us figure out what happens to the volume. When you're working through the table, if the two variables that you're working with are not directly beside of each other, they are inversely proportional. So it turns out pressure and volume are inversely proportional. Because I know that because they're not set up beside of each other. So the variables that are directly beside each other are directly proportional, like P and T are directly proportional. But P and V are inversely proportional. If I keep it in this order, I'll always know that when they're not right beside of each other, when one goes up, the other goes down. All right, and then how it changes is going to be by the same change, so it goes down by a factor of 2. That's what directly proportional is all about. If one variable increases by a factor of 2, the other variable decreases by the same factor. Yeah, so then if I need the volume started at 20, but it needs to go down by a factor of 2, is it going to go up or down? It's going to go down by a factor of 2. So what would it change to? It would change to 10. So it turns out if it needs to go down by a factor of 2, I'm going to divide by 2. So to make it go down, I need to divide. And that's how I'm going to get my final answer of 10. Meaning in my box, I'm going to put 10 liters. And 10 liters down here, that's my final answer. So if I need to make a variable go up, I'll multiply times whatever. Maybe times 2, maybe times 20 or 5, depending on what the problem's all about. If I need to make a variable go down, I divide. Yeah. Yeah, sign out, take a hall pass, and leave your phone in here. All right, what questions do you have about how I filled out that table? It's a lot at once the first time you see it. All right, let's go back and review like a list of steps. If you like a list of steps, you don't have to copy these at all, but I'll have these up here just for anybody who wants to check this out. So first of all, the effect. So that was the last row we filled in. For the column that is complete, that's where we had both the pressures. We had the 150 and the 300 in the column. We divide the big number by the small number, show direction with an arrow, then apply that effect to the other column. If it is a direct relationship, the arrows match. Guys, I'll know it's direct if the columns are directly beside of each other. So like P and T are directly proportional. T and V are directly proportional. And then V and N are directly proportional. And actually, even look at your chart real quick. What about N and P? They're not directly beside of each other, but they're directly proportional. So the ones on the end are directly proportional with each other as well. The only ones that are inversely proportional are P and V and T and N. So the ones that are separated, every other one, P and V and T and N, those two columns are inversely proportional with each other. That's where the arrows are going to be different. And then to find the missing quantity, if you need to make it go up, you multiply the initial times the effect. Or if you need it to go down, you divide the initial value by the effect. And then afterwards, it'll make sense. You can kind of check yourself to see if it went the right direction. All right, let's do another one. This is the one that's on the back of your handout here. A sample of gas has a volume of 20 liters and a temperature of 150 Kelvin. What is the new volume if the temperature changes to 300 Kelvin? First of all, does this question involve temperature? Is the temperature in Kelvin? Yes, we're in good shape. If it's not in Kelvin, we need to convert it first. All right, so first thing I want to do, I'm going to make a table. All right, what am I going to put across the top of that table? Henry, what 4 letters do I put across the top of these tables? Yeah, very good. And let's do it in that order that he said it so we keep up with our relationships. PTVn. All right, what goes down the left-hand side of my table? Jared? You got it. IF. Initial, final, effect. Let's put in the information we know and then cross out the columns that we don't have to worry about. Casey, what's the first thing I could put in this table and where would I put it? Good job. 20 liters under V. Went to the bathroom. Dalton, what else could I put? 150 Kelvin. What column will that go in?
T.
Good. And again, if you wrote your table small, you actually don't need to put units in the table itself. You just need a unit with your final answer somewhere under the table at the end.
Got the whole pass.
Oh, good. I don't know what Maddie took. Yeah. It says, what is the new volume if the temperature changes to 300K? Kendall, what's one more thing I can put on here? 300K. What column will that go under? T. Good. All right, looks like we can mark out a couple of columns. So Ian, what 2 columns can I mark out of this table?
Pressure and number of particles.
There we go. Pressure and number of particles can be excluded. So today we're going to deal with 2-column problems. Tomorrow maybe there'll be 3 columns or something. Okay, so that's where we're going with this eventually. All right, now I need to find the effect. Should I find the effect under temperature or volume at this point? Jade, where should I focus my thoughts right now to get the effect? You should divide. And am I going to, maybe it's just so obvious. Am I going to focus on my temperature effect right now or my volume effect first? temperature, because that's where I have a complete column, is what I'm trying to get to there. So I want to deal with my temperature effect. I'm going to divide the big one over the small one. So Ethan, what am I going to get for my effect here? 2. And then I want to put an arrow. Does the temperature go up or does the temperature go down from initial to final? Up. So I'm going to put up by a factor of 2. The times just means like by a factor of. So I did that. I divided the 300 over the 150 to get that. Always make sure, the way I'm doing these guys, I like to have a number bigger than 1 for the effect. So I always just divide the big over the small. Sometimes people say, do I do initial over final or final over initial? I don't know. Well, the answer to that is it depends. Just do whatever division. We'll do the big number divided by the small number so you get a whole number. Now, temperature and volume. Temperature and volume are directly beside each other here. So, are their arrows going to match or will their arrows be opposite? Maddie, what do you think about the arrows here? Maddie Sharfie. If they're directly beside each other and directly proportional, would the arrows match or would they be different? They're directly proportional. They're going to match. I know that they're directly proportional because the way I set these tables up, if the variables are directly beside of each other, they're directly proportional. So therefore, the arrows need to match. Gunner, pick your head up. Arrows match, and the number is the same number. All right, so that's what makes it proportional, is the fact that the arrows match here and that the number is the same. Well, this time I started off with 20 liters. That's my initial amount. If I need it to go up by a factor of 2, would I multiply times 2 or divide by 2? Multiply. All right, so that's going to give me my final answer here. So I got 40 liters. I'll box it in somewhere outside the table for an answer. I'll put it in the table too, just so I can see it there. So you always work these through the effect. You'll always have almost always have an empty box around one of the finals. You figure out the effect of one thing, use it to apply that effect to the other thing. All right, so we've got one more example to try. What questions do you have about this one we just did? You can always kind of check your answer in the end by making sure that the arrows either match or they're opposite depending on the kind of effect. And then look at the data to make sure if it's directly proportional. If one goes up from 150 to 300, the other one should have gone up, in this case from 20 to 40. Yeah. Sign out, take a hall pass, leave your phone in here. And when you come back, be sure to put the hall pass back in the box so we can reuse it. All right, last one to look at here as an example. If a gas in a closed container is pressurized from 15 atmospheres to 16 atmospheres, and its original temperature was 25 degrees Celsius, what would the final temperature of the gas be? All right, looks like this one is about atmospheres. What kind of a unit was atmospheres? Jordan, what kind of unit is atmospheres? PTVn. All right, atmospheres is going to be a pressure. All right, so we want to know atmospheres is ATM. It's a pressure. And what's the other variable in this one? He just went to the bathroom. Isabella, what's the other variable we're dealing with in this one?
Celsius.
We're dealing with Celsius, right? Are you allowed to put a Celsius in one of these charts?
No, Kelvin.
Only Kelvin. So as soon as you see Celsius in one of these problems, everybody, before you even start worrying about your chart or anything, I want you to find that temperature. And who remembers, what do you add to it to change it?
You just add 273.
You got it. So let's add 273 to that. Before you start working with these things, if you have any Celsius temperatures, you've got to convert them to Kelvin. So I want you to start making your chart and filling it out while I come around with some calculators, because this one isn't just a ×2 kind of problem. It's got more specific numbers on it. So if you don't have your own calculator, grab one when I come by. You're welcome. Got one. Go ahead and make a table. All right. Get the door real quick. Tanner, do you have your calculator?
Oh, yeah.
On the left-hand side, guys, it'll always be IFE for these things. All right, tell me a little something about your table so far. Brady, tell me something about your table. Pretend I've never done this before, and you got to tell me how to do it over the phone, and I can't see your paper. All right. You're a good start. Now let's get somebody else to help out. Brandon, tell me something else about my table. Pretend I've never done this before. What letter do I put at the top? PTVn. Good. Tyler, what can I do next? All right, 4 columns. Henry, what else can I do? You got it. I want to go ahead, step ahead. IFE down the side. Jared? Draw 2 lines across it. Good. All right, now let's start putting some numbers in there. Casey, tell me a number to put in this chart. Oh, good. 15 atmospheres under pressure. Maddie, what's something else, another number I can put on my chart now? Oh, sorry, I keep doing that. Maddie Ramey. You got it. I'm going to put a 298 right here. Again, as long as you're consistent with your units in the table, you can just put the number. I just need a unit for your final answer for sure. Good job. I got one more number I can put in here somewhere. Dalton, what's one more number I can put on my table? 60.0. You got it. I guess it is 0.0, huh? I'll put that on here. Great. Okay, tell me something to cross out. Kendall, what could I cross out of this table? Good. So even though you're like, why do I have to write these every time if I'm just going to cross them out? Part of the reason is, remember that order helps us identify our direct and inverse variables. That makes sure we don't skip over anything, so we know, in this case, they're directly beside each other. All right, P and T are directly beside of each other, so that means we're dealing with a directly proportional relationship. It's going to help us out. Okay, so Ian, how do I find my effect?
So for effect, you would divide 16 by 15.
Good. And did you do that yet?
And then
I need a calculator for that.
yeah, I got, for our effect, I got a factor of 1.067.
Okay, I'll call that 1.07. Maybe I'll round it there. Do I need my arrow to point up or point down here? Up, because it went up from 15 to 16. Up times 1.07. All right, so use the effect to find the other effect. If the pressure goes up, the temperature goes which way, Jade? up. And it goes up by the same factor. So once again, guys, I'm using the effect to cross from one column to another. So therefore, to find my final answer here, I'm going to take my original temperature, which was 298. All right, and then what am I going to do to that 298? Ethan, should I multiply or divide it to make it go up? Multiply it times 1.07. If you leave it in Celsius, you'll get the wrong answer here, so you've got to convert it. I'm getting about 319, I think it rounds to. And then always put your final answer somewhere down beneath your table or beside your table with a box, so we know why you filled out the whole table was to actually get a particular answer. All right. What questions do you have at this point? You think you could do a few of those on your own? Or if you need help, you can raise your hand. I'm here to help you. So this is the assignment. This one has most of the tables and grids drawn for you here. So this is what you're going to work on. What are you going to do anytime you see a Celsius temperature? Add 273, convert it to Kelvin before you get started with these things. So sometimes people like to go through at first, the very first thing they do is they go through the whole worksheet, find these Celsius temperatures, and go ahead and convert them so they don't forget. But you have the rest of the class to work on this. If you work the whole time and you don't finish, then of course you could finish it for homework, but I tried to get our notes at least started the other day, so then you have about 30 minutes to work on this, and I think you'll finish it. But I'm here to help you. If you want to sit down and work through a couple more with you, we can do that as well. So you just need to jump in and try them on your own before you even know you have a question. Once you're working on this for the rest of the class period, you can listen to music, but other than that, no phones out. We'll find something. Yeah, sign out the office. Yeah, you can just use IFE, PTVn, are the ones that you make yourself. And if you, same thing, you sign out, make that same hall pass, and leave your phone in here. You're welcome, Jared. If you're a little lost, please just raise your hand and ask. That's what I'm here for, and that's what I want to do for the next 30 minutes is help you.